Lordy, lordy, look who's 40. It's Enterprise Linux Security episode 40. How you doing, Joao?
Oh, all good, Jay. As always, it's a pleasure to be here with you for another episode. And yeah, we're running long. We should look into doing what other podcasts do, like breaking this up into seasons and having episodes and all of that for each season. But yeah,
Yeah, I thought about that, but then some part of me thought it might be a bit confusing too. But the audience can let us know what they prefer.
yeah, for us, it's not changed really.
Yeah.
We always have something to talk about regardless. And today we have something that we skimmed over when we talked about DevOps and DevSecOps a few episodes back. We talked about continuous integration and continuous delivery, but we didn't really delve into what it actually is and how it's implemented, and the benefits that it can bring your team, and the risks that it has associated with it. Because as everything, there's not just the positive side to it, there's also some negative aspects as well.
Yep,
And yeah,
absolutely.
today we're going to be looking at that.
Yeah, so it's a foundational topic. It's an important one. I have some experience. I'll probably get into my poor man's CI/CD solution later, but I have worked with DevOps and supported the tools that they were using. I think I started with Team City, which I really don't hear about anymore. I don't even know if it still exists. This is a while ago. Jenkins is another one, and Atlassian has one available too. But for whatever reason, I can't make the name come out of my head for some reason. So I supported the tools, but I wasn't the one that was building the build jobs, and I wasn't a software engineer. So there's still a ceiling here. But I think what we're going to do is just explain, like you said, what it is, why you would want to use it, what's good about it, what's not so great, and I think that'll be a great episode.
Okay, so let's get into it. The really simple definition of this, and again, all of these topics around DevOps and DevSecOps and whatever ops you're talking about that day, all of the topics around that have some nebulous meaning around it. That has some marketing behind it. That has some, I don't know, some creative thinking around it, but doesn't actually define what it is. Continuous integration, continuous delivery, it's just the process of automating your build systems, making sure that your developers, when they're writing code, they press a button to commit the code, it gets into your source code repository, and then a series of security tests are run on top of it. If everything goes right, then at the end of that pipeline, that build pipeline, then you'll get the actual compiled code. You'll get whatever it is that you're trying to build. But at its core, it's just the automation of all of those steps, of getting the security checks done, of getting all the static analysis in the code done, of making sure that all the libraries that are being pulled are the ones that you intended to. So it's not that complicated, but people try to make it look harder than it actually is. And this can be implemented in multiple different ways.
Yep.
At its most basic, if you've ever used Git, you have something called a hook. It's something that can trigger, say, a script or a command or something like that when something happens. Say, for example, a code commit is accepted into the repository, and you can have it trigger a script. And that script can have whatever you want it to have, including some type of security check, some type of reporting, some type of automation around that. And like you were saying, this can be a poor man's continuous integration, continuous delivery platform. It's not one of the big names. It's something that will get the job done in a pinch, and it's best to have that than not have anything at all. Because having this process automated and having this build process being reproducible, it's really important to making sure that your code quality doesn't drop and that you're ticking all the right security boxes.
And there's other uses for hooks as well. I remember at a company I worked with, there was a main repository, and I'm not a software engineer, but no one should be committing directly to this, but someone did a couple of times, and it resulted in like a whole day of wrangling the repository. So somebody actually wrote a post commit hook where if you try to commit directly to that repository, it says no, and then it just drops it. Just no, don't do that. And that's all it did. It was just I think a lot of these look at exit codes. They're pretty simple, and you're right. It's a very simple idea. At the end of the day, it's often a bash script, and then there's exit codes, and you kind of determine the flow of the script. And then we have the bigger solutions, such as I mentioned Jenkins, where you have a Jenkins server, and you could have agents as well that you could spread the jobs around through, and that helps the load. Also helps you do more at once. So there's solutions like Jenkins that are dedicated for this very thing.
Yeah, another platform that's very used in the open source space is GitHub itself. GitHub itself has GitHub Actions that will take YAML scripts that are then run in something that they call Runner, which are basically VMs or containers that they run on Azure that will execute basically whatever you tell it to do on those YAML scripts. And hackers, being the creative fellows that they are, they already found ways to abuse that, and we'll get into that further along.
I was already thinking that right before you.
Yeah, we just cannot have any nice things.
We really can't. And I remember working in an environment where CI/CD was a very prominent part of this workflow for these developers I worked with. And even though I didn't create the build jobs, it was still fun to see everything just happen when they put or they make a commit to the repository, and then you see the agent's CPU or one of them, whichever one it round robins onto, has very low CPU, and all of a sudden, bam, it just skyrockets and it's doing some work.
Yeah.
And then if other developers are doing work, the other ones will kind of spin up too. And then like exactly like you were saying, you get something compiled, it's finished, it goes through tests, and then obviously if it fails, then it goes back to the developer. There's something wrong with this. They get a chance to fix it. And then if I remember correctly, there was a code review, and then they would approve it for release after that. So they had a pretty good system going, actually. I thought it was really good. And it's probably not unlike how this process is for other companies.
Yeah. Some of the big projects in GitHub, they actually, whenever a commit is introduced, whenever somebody submits a new code change proposal, it will go through some part of this pipeline, and they will only consider it for acceptance if it passes the tests that are included there. So it can be a sort of they're going to be trialing the code before it makes it even into the source code. And this is really good because if the tests are properly defined, if you're looking, say, for, and we're going to go into what is actually tested there, but if you're looking for something like being susceptible to injection attacks, say SQL injections or something like that, and you can catch that early, it will never make it into the code base. So that's less bugs that you're going to have in the future. That's less risk that your application is going to get your users into. And that's an overall better experience for everybody. Sure, it might take some more time at the beginning to set all of this up and make sure that everything is running smoothly, but the payoff on the long run, it's really, really good.
Absolutely. It first starts out with, does it build, right? Because if there's some issue in the code and it cannot compile, well, it doesn't matter about security. Well, security still matters at that point because there's probably a way to get in the middle right in the process. But anyway, if it doesn't build, it goes back to the developer. If it does build, great. But are there security concerns like you said? So injection could be one of the things that's checked. There's all kinds of different things that basically I think anything that we've talked about in the history of this podcast could be a test in one of these jobs.
Exactly. And like with unit testing, then developers that are listening to us, if we have them in our audience, which I'm sure we do, they'll know what I'm going to go through here. But as in unit testing, the problem is in defining the scope of the test and making sure that everything is covered. Because you might have 100 tests to test a 10 line of code that you have, but if the tests aren't properly defined, if you're not making sure that you're actually testing the things that need to be tested, you might skip some stuff. So that's an important step there, is defining the scope, is making sure that all of the code is covered, that you have 100% code coverage. And when you don't, that at least you're covering all the inputs and all the outputs to making sure that nothing weird will enter the application. Those are usually some of the issues that applications are struggling to deal with, is when you get malformed inputs or unexpected outputs or something like that. And then that will mess up the logic in the application. So at the very least, start with those. Those are not the only ones that you should concern yourself with, but at the very least, start with those. Those are a good starting point. But yeah, let's look at some of the things that are tested here. The most basic is security testing. This is when you have a framework for testing that does things like fuzzing the inputs, where an application and Google has an automated tool that does this, something around monkeys, code monkeys, not code monkeys, bag of monkeys, something like that, that basically simulates keystrokes being pushed at an application, or just weird inputs going into all the fields of an application to make sure that it doesn't crash and that it doesn't do any weird computing with weird input. And it can be more even than that. It can be stress testing the application, say, does the behavior of the application change if we run 10 simultaneous instances of the application? Because that exposes some concurrency issues. You might be always opening the same file from each one, and then some of those won't be able to open it because it's already locked by another process. So running concurrency tests is also another interesting test suite that should be included in this. And this will bring to light I wouldn't call them the most obvious, because if they were obvious, they had already been caught, but the most egregious bugs that code might have, the ones that the developers missed by accident and that they can then look into and fix more or less easily. Then another thing that is tested is the static code analysis. This can happen even before the build, even before trying the build, because it will basically just look at the actual code. It will look for things like weird instances where you have, say, unending loops there, you have unexpected values getting passed to functions when they shouldn't be in those ranges, stuff like that, and static analysis can pick those things up. Those obvious examples that I gave, if you're a single developer on a very small code base, you'll catch that on your own. But if you're working on a large enterprise project with hundreds of thousands of files of code and many, many lines of code, nobody's going to have a holistic vision of the application. Nobody's going to be able to do that analysis manually. So you need tools that look at the code and look for those issues themselves. Yep. And that's a different step of this continuous integration and continuous delivery pipeline. Yep. When that is done, so go ahead.
I was going to say a lot of these, a lot of issues, like if you really want to throw a curveball at your software, just fill it full of emojis, input emojis everywhere. And I guarantee you'll find all the weak areas of your software, not all of them, but a good portion of them pretty quickly, because it's never expected. Your username is a smiley face with sunglasses. What? And it crashed the whole app. I've actually seen it happen. So there's all kinds of tests that I've seen while working with developers, and we have had emojis actually crash applications.
Yeah, because malformed input, or at least unexpected input, is something that applications are very susceptible to.
Yep.
It's why when you're reading an input from user, it's never just the case of reading the value that the user passes you. It's why all languages have stuff like SQL commands, where you have to pass the command and the parameters in separate variables so that you don't get weird stuff like that, because the language itself will perform those checks for you. But only if you tell it to. If you try to make it by hand and try to avoid those constructs of the language, then you're going to get yourself in trouble. Right. With simple stuff like that, just passing it, say, an emoji, or passing it UTF when it only expects ANSI or something like that.
Or if there's only 10 characters it's supposed to be, then you put 50 in there to see if it'll take it, and it does, and it wasn't supposed to. Fun times.
Funny that you mentioned that. Or, for example, passing it 10 characters as the password and it accepting it, then passing it 20 characters and it accepting it as if it was the one with only 10, so that you're truncating the size of the password that you accept and don't tell the user. That's a legit story that happens in production software, and I'm not going to name the company.
Well, I'm not either, but I've run into this a lot, actually, because I have really long passwords that are randomly generated. So when I sign up for a new service, for a new site, I create a brand new password for it. It accepts it. I log in. It's fine. My password manager remembers the password, and everything's good. Then later on, I find that I can't actually access the site anymore. And then I find out that it was only supposed to accept a certain number of characters. Mine was longer, but it just truncated the last part of the password and only accepted the number of characters that it was supposed to. It didn't have like bounds checking while you're creating the password. right? Is something like however many characters, and they're hoping that users are just going to listen and do exactly that. And I just come out with this really long password, and it happens so often that I can't even believe it. Then have to go and do a password reset because something happens to where now it is accepting all of the characters as input, where it wasn't before. It was truncating it. Now my password's wrong where it was right in the past. And yeah, you might think these things don't happen, but they definitely do.
Yeah, they do, and they happen in very high-profile applications. Another variation of that is when the application accepts a very long password and everything is fine, and they use the very long password, but they are only hashing the first 10 characters of it, and it's only storing the first 10 characters hashed, and the rest is a clean text as you typed it in. Again, another real story, a real application. I'm not going to name them. I have some friends there, and it's not polite to do that.
I'm not going to name any either that I found out was telling people you can't use that password because someone else has already used it. Again, we need CI/CD, and also we need some common sense too.
You can't make this up.
No.
It's impossible.
No.
Okay, another layer of the tests that are included in the CI/CD pipeline. Execution security. That means that it tests a running instance of your code. So it compiles it past the first few layers of tests that you sent it through, and now it will automatically try to run the application and then test against the running application. That means it will test things like configuration files that weren't included in the other layers. Testing interactions with, say, if it's a web application, testing the interaction with the web server, say with Apache or Nginx or whatever. And that will make sure that this integration does not add new security problems to the mix, because that can happen as well. So runtime execution security test is also a thing that it's another layer of tests that gets done here.
Mm-hmm.
I really don't like to rip on Java, but Tomcat integration tests are really tricky to do because of all the different versions and all of that. But I really don't want to get into that.
Yeah, I've been through it. I know exactly what you're talking about.
Yeah. Okay, so another, dependency scanning. We've mentioned this before. We've talked about hacks that were based on this before in the podcast. Attacking the supply chain, the software supply chain, is a thing. It's something that happens. It's been happening a lot. It's more on the news, say, over the past couple of years, but it's something that happens out there in the real world. It's not just something that you see on the news. So a test that is done, that should always be done, is that if there is any way to verify the authenticity of the libraries that you're pulling in, say through a signature, through a certificate, through making sure that the owner is who it says, and that the version is the one that you're trying to pull it in, then that test should go into the CI/CD pipeline. If something there is failing, then you really need to look into what you're pulling into the code, because it might have been tampered with, and this is the right step to find it.
Yep. Absolutely.
So, I mean, the reason why people pull libraries into their projects is obvious. Nobody wants to spend more time writing their applications than they need to. So if somebody has already created a library that fits their needs, they're going to use that library, and rightly so. It's just that you also pull in the security issues with that library has. You pull them into your code when you include that library. But again, this is something that we've already touched on. So if you're interested in this subject, just go back a few episodes and you'll find examples of hacks based on this and how this can be abused and is abused in reality.
Yep.
And if you're not convinced that this is a serious issue, then you should talk to your developers, because they'll surely understand it.
And it's something that can absolutely happen, just like we said before. Don't put too much trust in those libraries. Yes, they're probably fine, but there's always a possibility that they're not. So if anything's out of the ordinary, definitely take it seriously. And it might sound like we have all these problems with shared libraries, but we really just point out the few that are bad, because it does happen where there's probably thousands that are not. But I don't want to turn anyone away from shared libraries and think, well, I'm just going to create my own version of SSL or my own version of this. And I want to underscore, you are lowering security by orders of magnitude. by trying to create your own security libraries. Don't do that. Even though there could be some flawed libraries out there, they're still better than what you're able to create. I'm not insulting anyone, obviously. I'm just being honest because we're human and there's only so much that we can think of ourselves. And a lot of these libraries have gone through rigorous testing.
Yes.
Can still be problems, but they're still going to be ahead of you because if you're just starting out, I mean, these libraries have been out for decades. So unless you can compete with that, just use the libraries. But just be careful that you're, testing them like we're talking about here. And CI/CD is one of the ways to do that.
Yeah. So you have all these nice tests. You have your platform, say GitHub, and you're running this as GitHub Actions, like we mentioned before. You have your YAML file defining all the tests that you wanted to run. You're making sure that it ticks all the right boxes. And what's the catch here? Well, the catch is that malicious actors are pretty creative, as we've seen in the past. And GitHub, since they introduced GitHub Actions, they discovered that some people were introducing cryptocurrency miners into their build pipeline so that it would run inside of the VMs in Azure. And yeah, that's the reason why we can have nice things. And that's the reason that many limitations were introduced into GitHub Actions. We'll have a link to an article in the description that goes into detail and has some example scripts of how the attackers were abusing this. But basically, because these are simple scripts that get called at specific points, you can basically do whatever you want with those. You can pull stuff from the internet, you can pull other scripts into it, you can pull other executables. The idea is that you wouldn't attack your own build system, but in this case, you're just abusing GitHub's free infrastructure and making it harder for everybody else to do their jobs, basically.
And GitLab also has a similar feature as well for those of you that are on GitLab. I use GitLab, but I don't use that feature. So I'm really striking out when it comes to remembering the names of things today. I know they have a name for their feature too, but the same thing exists there. And my solution that I've come up with, because I tried Jenkins and I like it. So there's no, I'm not going to insult Jenkins. I mean, I decided not to use it, but the reason I decided not to use it is because I felt like it was overkill for just what I'm, doing here, at the company, which is and I think I've mentioned this before on the podcast, if not this one, then others, where I build everything via Ansible, desktops, laptops, servers. But how do I test it? Now, I don't think I've really spoken about that. So what I do, and I call this my poor man CI/CD solution, and I refer to it as that because, again, I'm not using Jenkins or any of the tried and true solutions for it. I have a staging repository. That's where everything goes when I commit anything to the staging repository, and nothing production relies on that. It's just completely, staging. It's just temporary. It's just something I want to test out. I have 4 virtual machines that each run a different Linux distribution. There's several that I run. There's Arch Linux, Debian, Ubuntu, Pop! OS, and I have a VM that runs each of those. So if I commit to that repository, the staging repository, that all the changes are tested on those VMs because that's the repository that they're looking for. And then as long as the messages come back successful straight across the board, then I commit it to the main branch and it's fine. And all I did was just create a cron job on these virtual machines that are just pulling it down and running it. Then it sends a message through my messaging service if there's a successful message or a failure. But it really, really helps. Even though I'm not technically a software engineer, I mean, I kind of am because I had like a Python series and I do know more software engineering than I'm willing to let on. I don't do CI/CD though, but it really has helped because I'll notice race conditions. So for example, it's putting a config file somewhere, but the folder doesn't exist because I have things in the wrong order. So I have to change the order, or there's syntax errors or whatever it happens to be. And it just keeps going. I even have like a security playbook that it goes through to make sure all my security tweaks are in there. And even though I didn't deploy something like Jenkins, you could still use this idea. So it's kind of like all in your imagination. You can, if you're going to be running a lot of these for a company, it probably makes sense to go with a solution. But if something like GitHub or GitLab is fine for you too, then that's cool. But it's really great how it just allows you to just test whether it compiles at all, or there's security issues or whatever it happens to be, and your pipeline should contain all the things that drive you nuts. If you run into a situation and it's a situation that can probably happen again, and every situation can happen again. I mean, you may as well just put that as part of your pipeline and then actually make that a test, and it'll actually save you a lot of time.
Yeah, and that's absolutely true. I agree completely with that. Having this whole process is something that's automatable, that's repeatable, that's reproducible. It's very important. It eliminates some of the randomness of the process. Say that if you are doing it manually, sometimes you might forget to call a specific set of tests, and then at the end you wouldn't remember that you forgot, and you would assume everything was fine when it might not be. So having it automated, it really is important for those. And we've learned over the years, as we do software development in the industry, we've learned over the years that automation does really help around all of these types of tasks. And that's why we're pushing so hard in that direction.
And no matter how good, I'm sorry?
We seem to be getting somewhere with this. Some of the changes that we've been trying to implement in the industry over the years are, I don't know, are vaporware after some time. We talk about them very much. They're the next big thing, and then after a few months, nobody remembers it and nobody cares about it. But the move to DevOps and DevSecOps has been going on for some time now, and it's really starting to see the results, to showing some results.
And you know, one thing that's really interesting that I run into quite often with my chain is that I actually have issues with libraries, or I should say plugins, but they're different but similar, right? Because they come from a different URL that's not mine, something that I don't maintain. So, you know, for me, I've actually had to build in logic for 404s because you know, a site goes down that I'm pulling something from. An entire Debian or Ubuntu repository goes down, and it happens more often than you think because you may not ever experience it if you're just running apt update every now and then. But if you have like you know, servers that are constantly building and pulling packages from repositories, you'll know right then and there just how often there's a blip in the repository, and it does happen. And then I'll start to get a failure, and I'm like, I haven't developed anything here for like weeks. I didn't make any changes. Why is it failing? Why?
Yeah.
There's a URL that's giving off a 404, and now I can't build until they fix it. So there's definitely some you know, logic here, and checking for 404s and scheduling like a repeat of the same job, which is one of the ways that I do it. Like, okay, it failed 404. Let's just schedule it again in 15 minutes or an hour or something. It runs again, and most of the time it's fine the second time around, which is always weird to me to see it.
You might just be hitting some throttling limits there on the other end. But
yeah,
regardless.
Well, yeah. But I would think not, because of it's probably not as many hits as I'm making it out to be. But what I've done is I've scheduled each of the jobs to never run at the same time. They literally pick a random minute. So it's very unlikely that two of them would hit the same repository at the same time. But you never know. I mean, that's why we do this, right? To figure this stuff out.
Yeah, and when you're paying attention, when you're running those types of scripts, more often than just the odd run that you do with your apt-get or your yam or whatever, it's interesting to notice how often there are issues on the other side, on the servers. And most of the times you won't even notice that because you're not hitting it that many times a day or a week or something like that. But some of those experience issues like every other day or something like that. And until you're looking at it really hard, you won't even notice that. But,
exactly. Yeah. I mean, you could be like, I don't know, Linus, who must have hit that repository while he installed Steam that one time in the wrong second and host his entire system. You never know, right? Maybe he should have used CI/CD in some way.
That was a very long burn there. That content was very old by now. Regardless, let's focus a bit more. Okay, so you have your CI/CD pipeline in place. You have all the tests that you want to run. You have everything lighting up green. All the tests go and pass successfully, and you have your application. Does that mean your application is completely full of issues? Well,
no, it just means your solution didn't find any issues. Doesn't mean there aren't any.
Yeah, there is that. It just means that the tests you created, the tests you configured there, didn't find any issues. There might be others that you didn't cover, or there might be some other things that happen. Let's take a practical example here. Say you have an application that's written some time ago, you pass all the CI/CD, everything lights up green, you do static analysis, everything turns out great, you pass it through some security professionals to audit, and they all come out, it has no security issues at all. Okay, everything is fine, your application has no security issues at all. It's probably the only application in the world that has no security issues, but yours doesn't. Okay, you're completely safe there. The next day, after you deploy your application, after you start releasing your application, distributing it, the next day there is a new vulnerability discovered in the language that you used to write your application. It's the same code that you had before, the same code that passed all the tests, that everything came out green, that there were no issues found, that still has no issues because the code hasn't changed. So it's exactly the same code. You have no problem in your application, but the language itself has the problem. Say it's something like an application written in C and it uses string copy, and string copy is known to be very bad, very poorly implemented normally. So then the application uses that at a few places in the code, and now your application, without any code changes, without no issues whatsoever when it was released, now has a security vulnerability. Through no fault of its own, through no fault of your developers, nobody missed anything, everybody did the absolute best that they could, and you have an issue, you have a security problem there. And that's something that happens. Going back to PHP, and there's a reason why I'm getting into PHP and Python as well, but I'll get into it. Going into PHP, PHP is one of those projects, this is going on a tangent from the CI/CD, but PHP is one of those projects that has their internal bug numbering system. They don't rely on CVEs like other projects do. And that's fine. But they have lots of issues, lots of security issues that they address that never get a CVE assigned, and they simply create the fixes for that, and then on the next release that comes out, all of that gets bundled in, it's released, and it fixes all the security issues. All fine and great. So your code now has a security issue. What do you do? What are your options right there? You have a very big problem. Your application has nothing to fix because there's nothing wrong with it. It's at the language level, but you have to do something. So you need to either change your code to avoid calling that function that you now know that has an issue. And the problem with that is that on a large enough project, any rewrite implies that you need the holistic view of everything. You need to understand how the application works to make sure that you get no unintended consequences with your fixes. So properly fixing something that might seem trivial, like just changing a function for something else, might introduce something unexpected in other parts of the application. Developers will confirm this. That's something that's really tricky to find. You might be introducing performance regressions. You might be introducing other unexpected behaviors. All of those things, through no fault of your own. You had the best code in the world, and you're now forced into doing this. The other alternative that you have is waiting for a new release for the language. Okay, this is what usually happens. For example, your application was written on top of Python 5.5. There were many security issues with it, and this is true. So Python 5.6 came out and introduced lots of security fixes. And the issue there is that when you move from 5.5 to 5.6, more likely than not, your application will no longer run. And why is that? Because, and PHP is specifically notorious for this, they introduce not only the security fixes, but they introduce breaking changes. They introduce deprecated behavior. They'll make sure that you're supposed to be using the language in the new way. So some of the changes they do basically are no longer support the code that you write for 5.5. So it will simply stop working. And now you're in the same situation where you have to refactor your code and reintroduce new changes just to get back to where you were before, that is with a running application. You had no issues before, and you are forced into lots of development time and development work to get back to where you were before. And this is something that's really tricky. And I'm going to shamelessly plug something that we are doing at Tux here that we are releasing right now that addresses specifically this. We are releasing extended lifecycle support for languages, including PHP and Python, which basically addresses specifically this issue. You get the security fixes without the language breaking changes. So if your application is running on top of a language and the vulnerability comes out for that language, that version, you get the security fixes and no breaking changes. You don't have to touch your code and it will continue to run. And this is one of the attack vectors that this proper CI/CD pipeline is not prepared to address. This is something that no matter how good your CI/CD pipeline is, you will never catch something like this, because this happens after the application goes through that pipeline. That happens when the application is already deployed or already in the wild. And it's something that in the enterprise we see a lot, because a company buys an application, say for accounting, and they expect it to last for, say, 3 years. And at the end of 3 years, they're expected to get the new version, and then after another 3 years, get another new version. But the thing there is that you might have budgetary issues. You might just be happy with the features that you have at the time. You might not need anything new for that application. You're perfectly fine with what you have. So you don't do any updates in that period. But the language level issues, they will continue to appear. You will continue to be vulnerable to new problems that are introduced in the language. And I invite everybody that's listening to try and go into one of the CVE trackers and look up the name of a language like, say, PHP or Python or something like that, and be amazed at the amount of issues that exist at the language level. It's mind-blowing right there. Mm-hmm. You'd be surprised by that. And that means that all the applications that run on top of that language are susceptible to that issue. Sorry for that. So through no fault of the application, you won't find there shouldn't be any need for any code changes at the application level to fix a problem that is not from the application. Okay? So the application developers, they're at no fault. They did nothing wrong. They shouldn't have to be spending their time fixing things that they didn't introduce there. And that's something that we address with those ELS products there. And it's really an interesting product. But yeah, that was a shameless plug right there. So that's very rare. Sorry for that.
No,
but I really wanted to address
that. So yeah. Awesome.
But again, all things that are often not caught with the CI/CD pipeline, even if you do everything right.
That's like the worst thing ever, when you can do everything right and still have a problem, right? You follow every security practice that you could think of. You do these things happen, and if it's at the language level, then that's even worse, because then it's like the very thing that creates your software has the problem.
And it's not only that. Take, for example, Python. When Python was upgraded from 2.7 to 3, the list of breaking changes and the list of code changes that you had to do to get your application running again is pages and pages and pages long.
Oh my God, it was a disaster. And it was one of the worst disasters ever. And I'm being completely honest here, and I love Python. It's my favorite language. So I'm not saying, not to use Python or anything. I love it. But there are some issues. And I remember when they first started saying that Python 3 is fully ready, you can start using it, there's no feature disparity. I forgot how they worded it, but they said something along the lines of everything's been ported over to Python 3, so you won't have any issues with compatibility. And I was sitting there with at least 2 things that I couldn't use anymore, that 2 popular libraries. I can't remember what they were. One of them was Pygame, which is very popular for those of you that like to develop computer games. There's an entire library just for that. And for a year, I was unable to use that library because it wasn't ported over, among others. But meanwhile, they were saying, everything's ported over and it's fully ready. No, it's it's not true. Stop saying that. You're most of the way there, yeah, but you're not all the way there. So there's a legit issue there, or there at least was. I don't think I run into anything anymore, in 2022. But I think even like a couple of years ago, I was still running into problems.
And you're running into problems because specifically for Python, it's used not just for developing for full-blown applications, but also used in scripting, and in many system administration tasks and system administration applications rely on Python scripts. And whenever there's a change like that that's forced on you, your code just breaks. So all the scripts that you've been hoarding for years no longer work properly. And the main difference there, and this is a bit of a tangent again, but the main difference is when you do the change at your own pace and you do the language level update at your own pace, or when it's forced upon you because of some vulnerability that you need to address. For compliance reasons, companies have to address security vulnerabilities within a certain time frame or have a plan to how to address them. So when they're faced with the language level vulnerability that affects applications that they use, they're really up against the wall because there's not much other choices. They need to update the language, and that will break the application, so they'll need to fix the applications or buy new ones. And that's it.
Right.
Developing, doing the changes yourself, developing the code, all of that takes months if you're lucky. It's a very large task just to address a security issue that you shouldn't be addressing. Okay. And this is an alternative that helps you solve that problem.
And here's an interesting thing about that too. Like, keep in mind, you could be using a non-rolling distribution and you're only installing security updates. That's all you're doing. And the security updates include more than you thought about that language, more than it should have. It should have been security fixes only, but then it doesn't compile anymore. And here's an interesting experiment if anybody's interested in this. If you create a test VM, it cannot be important. It should not have any important piece of data on it at all. Just put some code in there, code that you're okay, or your company's okay with you doing this, or if it's your own project, obviously your own boss. But just get it set up on that VM and make sure it compiles and runs. And then take an image of that VM or a snapshot or export it in some way, freeze it. Don't let it change, but don't use it because we're going to not update it. So what I'm asking you to do is fully update it, run some code, compile it, and make sure everything works. Then take an image of it, delete it, because we don't want anything in existence that hasn't been updated or isn't going to be updated. This is just a test anyway. Wait a couple of years, and then get that same image, create a VM from that image. Again, isolated environment because it's not updated. And then just simply try to update it. Just install all of the updates and nothing else different. Same distribution, and see if your code compiles. I bet it won't. I'll bet it won't. That's just my prediction, but it'll be fun to see if anybody wants to try it.
And that's probably true for basically any programming language out there.
Right. Absolutely. It probably won't compile. And all you're installing when a couple of years down the road, when you revive the VM by creating a new instance, all you're doing is installing security updates. It shouldn't change anything other than you have fewer vulnerabilities, but then your code doesn't compile. What's up with that? Well, that's the reality of it.
Yeah, and this is a serious issue. Even for companies that have fully embraced DevSecOps and DevOps and all of that, and have all the right tools in place and all of that, they still get blindsided by issues like this. They have applications that are important for their line of business operations, and just because of security issues, they're forced into operations that they don't need.
Yep.
This is basically the last thing that you need as a sysadmin, is being forced into changing your operating systems or changing any package version or something like that for some external factor that you don't control, like a security vulnerability. Sure, you should always be up to date. You should always follow the best practices, and that's why you're going to do the update. But it's forced on you. It's not something that you have the time to plan properly. You don't have the time to test properly. You don't fully understand the ramifications on other unrelated systems. And it gets really tricky really quickly. So even if you're fully into DevSecOps, if you have your CI/CD pipeline fully in place, if everything is testing okay, that does not mean that there are no issues at all, because the issues might not be in the application itself.
Yep, and that is just so true. And it's just one of those things where I think what this is pointing to is the beginning of a shift in how we package things, because we're coming out with all these different technologies. There's Project Atomic, if you're familiar with that, where they're trying a completely different way. Then we have SUSE trying a different method. I think they call it ALP, Advanced Linux Platform, which is going to be, I don't know if it's completely container-based, but it's a transactional distribution. And then you have Flatpaks and all these other ways of delivering things. Containers, obviously, because that's the elephant in the room. Containers, of course, are going to be a part of the workflow as well. And we have all these different technologies that work, but they have big flaws too. Nothing is perfect, and none of the technologies that we've come out with solve all of the problems. And I think eventually we're going to see that everything is shifting towards locking things down even more to where they can't change, and lots of things being read-only. But until then, all we could do is just try our best and just keep our eyes on the release notes. But I think the worst part about this is that depending on which distribution you use, when you install your updates or before you install your updates, you might check the release notes. If you rely on Python, for example, you might look at the release notes for that package and you might find security fixed, security fixed, security fixed, and then feature deprecation. What? Okay.
And that's
but
the one that hits you.
That's the one that hits you. But what's even worse is depending on your operating system, you install that Python update, it might just say security fixes. Doesn't tell you which ones or any information about what it contains. But now you as the administrator, if you had the time to read every single word in the release notes, well, it took you a few seconds to read that one. There really isn't anything there. So it's especially not your fault then, because there's really no way that you could have known because the information is not even present with the update.
And that part about the PHP project not relying on CVE for all of the security issues, that also affects what you're just mentioning, because many of the tools that are used to do vulnerability management and assessment will only look at stuff that has a CVE assigned. So when it does not have a CVE assigned, it will not be picked up by those tools. And the problem will still be there. Okay, so that just compounds the issue. This is different than an operating system level vulnerability. Say your application is running on top of Ubuntu, the latest version, and the vulnerability comes up on Ubuntu. Ubuntu is just the environment where the application is run. You can probably run it on a different distribution and everything will be fine and you'll avoid the vulnerability altogether.
Mm-hmm.
Having a language level vulnerability, that's foundational for the application. That's like taking away their support infrastructure and all of that. It just crashes down. There's no way to avoid using that language on the application that you already have. So even if you move it to a different system, it's still the same language, it's still the same version. You might have upgraded the operating system multiple times. As long as you maintain the same language version, the application will continue to run until something like this happens. Years might go by after the application is released, and then you get hit by something like this. Everything else might be out of support. As long as there are no security vulnerabilities left to address, then the application is perfectly safe to run. But if something comes along after that time, then you're left on your own and your only recourse is either updating the code or updating the application. None of those are very good prospects.
No, I feel like we're just trying to do the best with what we have and what we have. We don't have everything we wish we had, but we have what we have and we're doing the best we can with what we have. But at the end of the day, it's always surprising. I mean, technology is always surprising to me because, just as a recent example, not related to any of this, but it is an example of how temperamental technology is. I have 2 Proxmox servers, same motherboards, same everything, completely identical. They're not, failover because you need 3 nodes, but they are in a cluster so they could see each other. And they use a 10 gig card. And then one of them is the same model of 10 gig card on both servers, same SFP connector, same cable manufacturer, identical, right? But this one in particular is now saying that the 10 gig card is just dropping off the bus. Why is it dropping off the bus? I have no idea. But, here we have something that has been unchanged and, or at least other than security updates, and then it just decides not to work. And this is our industry. I'm not complaining, though, because I do like detective work. So I'm going to figure this out, obviously. But and getting back to CI/CD, it's like the idea is you're trying to eliminate as many of the errors and security issues that are common as you possibly can. You're not going to think of everything. You're not going to have your pipeline have everything inside of it that it could possibly have for your app to make it 100% perfect. But what you are doing is you're enabling yourself and your dev team, if the dev team or dev person isn't you, more sleep because you're eliminating as many of the common things as you possibly can, which also allows you to focus on the things that you otherwise wouldn't have time for if you were chasing all those little things. Maybe it'll give you time to add a feature improvement that you really wanted to do and never had the time to do. So it really does enable you as the developer to do things you wouldn't have the time to do, but also you're still going to have the sudden tech debt weekend scenario happen. That's just the way it is. But then again, we're smart people. We love what we do, and we're just going to keep figuring it out.
Yeah, absolutely. Don't get the wrong impression. CI/CD is foundational for SecDevOps and for DevOps at some point. It basically allows you to move from one to the other. But just don't get the idea that sometimes people try to pass along when they're describing these types of approaches to system administration. Don't get the idea that it will be your only solution and it will solve all your problems. It will address many of those. It will improve the security of your code a lot. That's undeniable, but not everything will be caught by it. Okay, so it's much better than not having it. No discussion at all right there. You should absolutely try to move in this direction. And this isn't something that you're going to do on your own. This is something that you need to get buy-in from the whole company. You need to get buy-in from the developers. Everybody at every level has to agree that the change has to happen. And this is a change in the way that the processes happen inside the company. It's not just the technical level, it's the way that people approach security. As we become more aware of the security issues and we become more interested in solving security issues, we need to adjust the way that we do things. If we continue to do things the way that we've always done it, we'll continue to always have the same issues that we've used to have. So the change is needed, the change is good, but it will not give you, this is something we said before as well, nothing gives you 100% safety. This won't either, but it will get you much, much closer.
And it'll at least help take care of the low-hanging fruit that is often used first before anything gets too, aggressive. I would say it's not a best practice because I don't like that word, but what it is a minimum practice. These are minimum practices that you have to do at a minimum to give yourself a base level of fewer low-hanging fruits as possible. And another thing I would say too is that unfortunately the reality is, and as much as I hate to say this, there's a lot of companies out there that will never consider this. They'll never consider CI/CD. And you as the administrator, you might be banging that drum to the executives like we have to do it, we have to do it. Yeah, not right this quarter, not really on our ballpark right now. And then it takes something bad happening. Then, oh, we should have listened. Yes, let's do the thing. But I don't like it to get to that point. The only thing I could think of is pay attention to the security blogs. If there's anything that companies should have had CI/CD and it's in the article, but they are an unfortunate victim, bookmark it. Bookmark all the security stories that are examples and keep them because you could use them as examples for why the company needs to do something because these other companies had a problem. And maybe some of those articles, a company didn't have CI/CD. Maybe there was a big build error that got pushed out and caused like millions of dollars in damages and lost revenue. And then if you present that article to the executives, see what happened to these guys? Like we can totally avoid that. We could set up a CI/CD solution. It'll take a while to build. It doesn't happen overnight. And you're never done because you're always adding things, but it's going to help. And it's going to take away those most of the low-hanging fruits that are going to be the ones that are most likely to bite you.
Yeah. And if you're thinking, yeah, we've had CI/CD at our company for years, what are you guys talking about? Well, out of all of the companies out there, the vast majority are not very large companies. The vast majority don't have the resources to put this in place properly. The vast majority do not have this in place. So the idea here is that we all improve as more people get into this, because there will be less vulnerabilities overall, and this helps everybody. It's not only your software, the one that you're developing at your company that's safer, it's everybody else's as well, because there are less attack vectors open for people to exploit, for machines to be abused, and then used as stepping stones to other machines. So the more we invest in security, the more we invest towards a more secure development environment, the better it will be overall for everybody, not just the ones at that specific company, not just the people inside of your team, but to everybody that touches the IT in some way.
I would say, two things I'll say to that. One, it is a little tedious to me when I read comments in any of the work that I do, where either it's this podcast or it could even be a video. It doesn't really matter. And I'm talking about something that I think all companies should do because it's really important. And, there's actual evidence that shows that companies should probably be doing that. But then I'll get a comment like, well, that's not an issue because, my company's been doing that forever. We've never had a problem. I remember when one time I was talking about operating system migrations and how difficult they are. And someone responded, well, it's not difficult for us at all. This isn't a real problem. It's easy. We just, okay. It's great that it's easy for you. And I'm happy that your company apparently doesn't have the problem. But also keep in mind the fact that we mention it on the podcast. We're not going to mention something that isn't a factor for a lot of companies and probably the majority out there. Maybe not the majority in this case, but a high number. There's always a reason for it. And trust me, you'd be surprised how many are not doing these things because it's, very important. But sometimes getting buy-in, like you were saying, that's often the hard part. That's really an issue for a lot of people.
I saw this quote somewhere, I can't recall whom, but yeah, security is a people's issue, not a technology issue. We have the technology to solve all of these problems. We just don't get the people to use it properly.
Yeah, maybe we are actually utilizing quantum computing already, and we can't know it because we observe it and then we're not using it anymore. But if we are, then every time we observe something that fixes something permanently, then something else breaks. We always have something to fix because everything is constantly breaking. So maybe we're dealing with a quantum nature. Okay, I'm just getting into science fiction at this point. But the point is, these are minimum practices. You should definitely have these things in place. And it's, like I said earlier, it's not going to be quick. You're not going to find a turnkey solution that you'll install today. That's all you have to do. And then it just runs forever, does all the things. Just like configuration management, you're always going to be tweaking it. You'll always find new things that you should be checking for. Sometimes it takes somebody in the company to make a mistake that you didn't even know was possible to be made. And then from that point on, that's a part of your pipeline and you just keep going. And I've seen companies where they start out like everybody is stressed. They're working long hours. You could tell the morale is down because they're so overwhelmed. But then when it's realized that they can implement these things, then their workload starts to go down. They're able to utilize their creativity. And next thing you know, people are leaving at 5 most days, not all, it's still IT, but they're leaving at 5 in the afternoon most every day, when before they were lucky to leave by 8. And you'd be surprised because these things really do help. And I've seen it completely transform companies. So if your team is constantly overwhelmed, maybe it could be because there's some automation or checking that could be done. Who knows? But it's worth having a look because living at 5 every day, that's important. Mental health is really important.
Absolutely. And if you're thinking that this is just something that's too complicated to implement, that you're never going to be able to get around it, try something small, something simple first. Make your first test if your application, say, for example, creates a file on output, your first test could be checking the permissions of the created file. Make sure it's the permissions that you want it to have. Make sure you're not giving it extra permissions by accident, for example. That's a simple test that you can do, very easy to implement, and it starts you on the right path to understanding the scripts and the flow of all of this.
And you might even, I don't know, have fun. It might be fun for you. I mean, I didn't think network administration was going to be fun. Now I can't get enough of it. I didn't really think configuration management is going to be fun, but I'm obsessed with it. You never know. You might actually have a chance to flourish in your company and really transform. And I think that would really set a good tone. So, yeah, there's definitely a lot to say about this. And now that we have this foundational episode complete, I would say we'll probably be referring back to this one a lot because I have a feeling there's going to be some situations where this could have helped a company. Remember that episode number 40 that we did? Yeah, I might want to look
check
at that
they
one.
missed.
Yeah.
That's a check you want to add on your CI/CD pipeline.
Absolutely.
We're probably going to be referring to that a lot.
So yeah, we pretty much I think we went through the topic, and this is one of our longer episodes, but I think it's an important one because ultimately, these things do matter. They can really help, and like we said a million times, it's not going to catch everything, but it does catch a lot of the low-hanging fruit. And the low-hanging fruit is some of the most egregious because that's the first thing anyone, threat actors are looking for: low-hanging fruit. If you have fewer low-hanging fruits than other companies, they'll hopefully skip your company or get tired and go on to someone else. As long as it's not a targeted attack, I think it'll actually benefit your security quite a bit.
Absolutely. Thanks everybody for listening. Sorry that it's so long, but yeah, this is a pretty interesting topic, so we could prattle even for longer. So again, thanks everybody for listening, and until the next one.
See you later.
Bye.